All right, so we just introduced the concept of classical probability, and we're going to employ that idea to calculate a particular probability. In this case, we're going to be figuring out exactly how likely it is that we get dealt a blackjack in the game of 21. All right, now 21 is a popular casino game. Some of you may have had the opportunity to play it before. But those of you who haven't, in this game you start off by being dealt 2 cards out of a 52 card deck. And the best outcome that you can possibly achieve is to have the sum total of your first 2 cards equal 21. Okay, now this can happen only one way. Okay, you need one of your cards to be an ace. Okay, so let's say that's an ace. And then, along with an ace, you need the other card to be worth 10 points. The ace is worth 11 points, and then we match that up with some 10-point card to make 21 on those first 2 cards. Okay, now there are several different cards that can be worth 10 points. There's the 10, a jack, a queen, or a king. All of those in this game, at least, are worth 10 points each. So an ace matched with any of these 10-point cards gives you a blackjack, and you get actually paid extra money if you should happen to hit that hand in a casino. So how do we calculate how likely it is to get this blackjack? All right, that is, what is the probability of B, where B is the event of getting a blackjack? Well, classical probability tells us that if we can figure out the number of ways that we can make a blackjack, just count up how many possible combinations of the ace and the 10 there are, and then divide that by the total number of outcomes that we can have when we're dealt 2 cards, that will be the probability of getting a blackjack. Okay, so this is our goal. It's what we're setting out to find. Okay, so we're going to be doing some work that is specific to this problem, and in the ensuing sections we're going to talk about a more generalized approach that you can employ in lots of different settings. But our first exposure to this, I'm going to make it very concrete. Okay, we need to count up the number of ways to get a blackjack and the total number of possible 2-card combinations. All right, so let's do the numerator first. Sometimes the numerator is easier to do, sometimes the denominator. It's going to depend on the setting. So what is NB? Okay, what is the number of ways that we can make a blackjack? All right, well, I've already described how a blackjack can happen. You need to have one of the aces matched up with one of the cards valuing 10. Okay, there are 4 aces in the deck, and there are 16 cards valued 10. Okay, the 4 tens, jacks, queens, and kings. 16 total. All right, so every single one of these aces could potentially be matched up with any one of these 10s to give us a blackjack. All right, so the total number of ways that this can happen, if each ace is matched up with 16 10s, and there are 4 aces, it's going to be 4 times 16, or 64. Okay, so this is the number of ways to make a blackjack, and I'll circle that in red, because we're going to need to use that to finish our calculation